example from our homework with linear regression and correlation. So this is the scenario. A bank administrator wants to analyze age and savings amounts for 8 of their customers. The data below is age of the person and how much in savings that they have. And the question is, can you predict how much savings a person would have based on their age? So what I always do is I open up this scenario, blank predicts blank, whatever I put in the first blank, and it said, can we predict the savings by age? So we're wanting to know, does age predict savings? And if you do this every time, then X is the variable in the first blank, Y, or your dependent variable, is the variable in the second blank. So it's important to know that we have different names from our variables. We have predictor variable and response variable, X and Y variables. Excuse me, and our independent and our dependent variables. So on this problem, X is the age, it's our predictor variable, or our independent variable. We would also call that our independent variable. And Y is our response variable, which we also call our dependent variable because it depends on your age. So then the question asks, which variable should be your dependent variable? And the answer is savings to the nearest dollar amount. And then, and we're also asked what should be the independent variable, and that is age in years. So that's usually your first few questions to understand. After that, the questions are going to depend on what you put in Minitab. So in Minitab, you need to go ahead and put in your data in 2 columns. And then you're going to go to Stat, Regression, and Fitted Line Plot. Then you'll enter. When you do this and do it correctly, then you will get the following information from that. You'll get the regression equation, you'll get the R squared percentage, and you'll also get the F, which in this case is the test statistic, and the p-value, which we'll use here in a little bit like we do in all our hypothesis testing, is 0.309. So the next questions usually are, what is your y-intercept, and round it to the nearest whole number. So if I come back up here, what you need to remember with the regression equation is that the slope is always attached to the variable. So 8.683 is our slope because it's multiplied by our variable over here. The other number that's out, what I say is out by itself, is our y-intercept. So now we can answer that the y-intercept is negative 15816, rounded to the whole number, and our slope then is 683. Remember that when we were in an algebra class, the equation was y equals mx plus b, and in this case, that is the same formula, only they're kind of backwards in Minitab, so it's b plus the slope times the variable. So b being your y-intercept, in this case, negative 15816, and your slope is slapped up against the variables, what I say. So it's 683. So hopefully that helps you determine what the slope and y-intercepts are. Then if we come to the next question, it asks us what our R value is. Well, to find the R value, you can find everything in the first Minitab steps, which we'll see as we go through this problem. We'll find everything under stat, regression, and fitted line plot, except for our correlation coefficient for our sample, R. So this is what you have to do to find R. You will go to Stat, Basic Stats, and click on Correlation, and it will give us R, which again is our correlation coefficient for our sample. And that R, you'll see right here under the plot of the points, is 0.413. So that is what your answer would be. What I also want you to realize is that I'll review that for you. If R is 0, that means there's no correlation. If it's, say, between 0 and 0.4, so that falls in here, would be weak positive. This would be moderate positive if it falls within here, and this would be a strong positive. The closer you get to 1, the stronger your correlation is. The closer you get to 0, the weaker. Same thing on this side. So this would be a weak negative relationship. This would be a moderate negative relationship if your R value fell between negative 0.4 and negative 0.8. And if it falls in between negative 0.8 and negative 1, then you would say that's strong. So again, as it gets closer to the ones on either side, negative or positive, it gets stronger. And the closer you get to 0 in the middle, the weaker our correlation is between the two variables. So since this one is positive 413.413, it falls in here, and that's going to be a 0.413 falls in here, so that means that will be moderate. Again, weak, moderate, and strong. So moderate, positive relationship between the two variables. Okay, then the next question asks, what's the R squared value? We got that from the first time in Minitab. It gave us that it's 17.08%. So you would write in 17.08%. And what that means is that approximately 17.08% of the variation of the Y variable is actually determined by the variation in the X variable. In this case, that is savings and age. So that means only 17% of the variation in the savings amount is actually determined by the variation in age, and that's not a very large percent. That means the rest of everything, let's just say it was 17%. The rest, which would be 83%, is coming, that variation is coming from other variables and outside things. So that's a pretty low R squared value. To move on, the next question is using a 0.05 level of significance. Is there a correlation between age and savings? So this is where we need to run. This came from our first use in Minitab. We got the p-value and we got the test statistic. So this is our p-value 0.309. Our test statistic is 1.24. And if we are going to use the 0.05 level of significance to find out if there's a correlation, it's time to do our hypothesis test. And our hypothesis test in a correlation and regression problem, you always just use rho. Rho is this fancy little p, and it is the Greek letter that represents the population correlation. So if rho is equal to 0, there's no correlation. And if rho is not equal to 0, there would be significant correlation. And that is our null hypothesis and our alternate hypothesis. And those will be your hypotheses every time in this type of problem. So then we do our hypothesis test, and we know to do if p is less than or equal to 0.05, then reject the null. P is 0.309, which is actually not less than or equal to. Since it's not less than or equal to 0.05 or 0.050, then we fail to reject the null. That means we accept the null. And if we accept the null, that means that there really is no significant correlation between age and savings account. Okay. Once we've done that, our next question is going to ask us, well, then can I make predictions on this model? If there is a correlation, so if you chose the alternate hypothesis, then you would say, yes, there is a correlation, and so then you can make prediction based on the model. But since we found there's no significant correlation, then it follows and makes sense. Since they're not correlated at all, then we cannot use the model. So that is what we're answering here. And then the final, I want to go ahead and go through the final step here to show you what to do if you could make a correlation. So had we rejected the null, we would have found that our answer would be that there is a significant correlation. And if there is a significant correlation, then you'll be able to make predictions and then you would be able to do what I pretty much call from algebra plug and chug. So if you can make predictions, if a person is 30, what would their savings amount be? So if we had rejected the null, there would have been a correlation, and all you do is plug in that age to find out the answer. So the savings would be equal to, and this was our regression equation, and we would plug in where the age is 30. And once we plug that in and use our calculator, we find that if a person is 30, that their savings would have been $4,674. So I hope that helps you be able to go through all the steps in hypothesis testing.